Okay, good morning all. So we will continue with non-face-to-face week 2, which is still in chapter 1, Introduction to Organic Chemistry. Okay, so now we will look at subtopic 1.3, which is classification of organic compounds. Okay, so at the end of this lesson, you should be able to define what is functional group. Okay, and then you should be able to name different functional group. Classify organic compounds according to their functional group. So the main thing here, you should be able to see the difference between functional group and class of compound. Okay, alright. And then we will also look at homologous series. Okay, so you will learn what is homologous series. Basically, each homologous series, they have a particular general formula. Okay, and then members of the same homologous series, they will have the same functional group and chemical properties. Okay, so you will also see how the change in physical properties happens in a homologous series with increasing number of carbon atoms, and successive members of a homologous series will differ, which means the previous member and the next member will differ by a CH2 unit. Okay, finally, we will also look at the ability of carbon to form 4 covalent bonds. Okay, so carbon is in group 14, so it can form 4 covalent bonds with other carbon or elements for it to be obtained. Okay, so either it can form a single bond, okay, it can form a double bond or a triple bond with another carbon or other elements. Okay, so first, what is the definition of functional group? Okay, so functional group basically means an atom or group of atoms joined in a specific manner, okay, which gives the chemical properties of the organic compound and are the centers for chemical reactivity. Okay, so basically it means that each organic compound have their own functional group. Okay, and the functional group is where the reaction happens for that compound. Okay, alright, so it's a way to classify organic compounds. Okay, and then you will see that we will also learn about naming organic compounds. Okay, and naming organic compounds will be based on their functional group. Yeah, okay, and functional group also determines the physical properties and also how the molecules react, which means their chemical properties. Okay, okay, so like I've mentioned earlier, okay, so functional group is the reactive part of a molecule. Okay, so in coming examples, you should be able to identify where is the functional group and what is the name of the functional group. Okay, so let's look at an example here. Okay, so here is a molecule 2-propanol. Okay, it's an alcohol. You have an OH group alcohol at carbon number 2. Okay, so this is the functional group for alcohol. Okay, so any reactions involving alcohol will occur here at the OH group. Okay, alright. Okay, so there's few examples of reaction here. Okay, so just have a look first. Okay, so in this first structure, what we have here is an alcohol, 3-butyl alcohol. It can react with hydrochloric acid, HCl. So basically what happens in this reaction is the OH from the alcohol will be replaced by chlorine from HCl. Okay, so this is the product, and then you will get H2O as a byproduct. Okay, next example, what you have here is ethyl chloride. This is an haloalkane. Okay, haloalkane. Okay, again you will learn about the namings later on. So it can react with sodium hydroxide. Again, what happens here is chlorine here will be replaced by OH from NaOH to give you an alcohol, and byproduct NaCl. Okay, so like what I've mentioned earlier, okay, so reaction happens at the functional group of a molecule or a compound. Okay, so now we will look at individual class of compound and their functional group. Okay, so first we look at alkane. Okay, class of compound alkane. Okay, so for alkane you must know that they do not have any functional group, any particular functional group. Why? Because as you know, okay, alkenes, they only contains carbon and carbon hydrogen bond, okay, all single bonds. Okay, all right. For example, you have here ethane. Okay, let me just draw the expanded structure for you. Okay, all right, CH3 CH3. Okay, so if you notice, everything is identical in terms of carbon hydrogen and carbon bond. So that is why alkane, they do not have any functional group. Okay, so for naming alkanes, which we will learn later on, so you should know that alkanes, their names will end with A and E. Okay, for example, this one, it has 2 carbon, so the name is ethane. Okay, all right. Okay, so alkanes, they have no polar bonds. Basically, alkane molecules, they are non-polar. Okay, and then they have no lone pairs and no pi bonds, which means they don't have any double bonds or triple bonds in them. Okay, so it has no reactive site. So that is why alkanes, they do not have any functional group. Okay, okay, so next we look at alkene. Okay, so alkene, the functional group is the carbon double bond. Okay, so how do we identify alkene? Is when we see a carbon double bond. Okay, so what I want you to know here is, for the class of compound alkene, the functional group, we call it carbon double bond. Okay, so this is the functional group for an alkene. Okay, so you have an example here, ethene. Okay, so I can draw the expanded structure for you to see. Okay, CH2 CH2. Okay, so this is ethene. Okay, so as for alkene, it ends with E and E. Okay, so you should be able to circle the correct region. For example, when you see an alkene, okay, the functional group, you should know it's carbon double bond. Okay, so you should know this is the region that you should highlight. Okay, next we look at alkyne. Okay, so alkyne basically refers to carbon triple bond. Okay, carbon triple bond. Okay, so the class of compound is alkyne. The name of the functional group is carbon triple bond. Okay, so again, take note for the difference between class of compound and their functional group name. Okay, so there's an example here. Okay, this is ethane. Okay, or acetylene. Okay, so you can see it has a carbon triple bond here. Okay, right. So for alkyne, they will end with Y and E. Okay, okay, next we look at aromatic compounds, or we call it as arene. Okay, so aromatic compounds, usually they have alternate single and double bonds. Okay, for example, if you look at the structure given here, okay, benzene, this is benzene ring here. So if you see, they have alternate double bond and single bond. Okay, they have alternate double bond and single bond throughout the ring. Okay, all right, so the functional group for aromatic compounds, we call them as aromatic ring. Okay, and then they don't have any specific name ending for aromatic compounds. Okay, next is alkyl halide. Okay, so alkyl halide or haloalkane. So what it means, basically, it's an alkane which has halogen functional group. Okay, so the functional group, we call it as halogen. Okay, or halogen. Okay, so the halogen can be any elements from group 17. So it can either be fluorine, chlorine, bromine, or iodine. Okay, all right. So as for the naming, you will learn later on how to name haloalkane. So this is an example of chloromethane. Chloromethane. Let me just draw the expanded structure for you. Okay, it's CH3 Cl. Okay, all right. Okay, and then one more thing what you should know is halogens, they are more electronegative than carbon. Okay, so that is why you see a partially positive at the carbon and partially negative at the halogen. Okay, again, haloalkanes, they don't have a specific name ending for them. Okay, next we look at alcohol. Okay, so for class of compound alcohol, their functional group is OH. Okay, COH. Okay, so the name of the functional group is hydroxyl. Okay, so you see the difference. The class of compound is alcohol, but the name of the functional group is hydroxyl. Okay, so it has OH, carbon attached to OH. Okay, so this is an example. Okay, methanol. Okay, alcohol with one carbon, we call it methanol. And alcohol, their name ends with OL. Okay, they ends with OL. Okay, next we have ether. Okay, so class of compound ether. Okay, so how to identify ether is, okay, so you have carbon bonded singly to oxygen, and another carbon is also bonded singly to oxygen. Okay, so this is how you identify if it's an ether. Okay, COC. Okay, single bond between the carbon and the oxygen. Okay, and the carbon is octet, on the left and on the right, it's all octet. Okay, and it forms single bond with the oxygen. Okay, so for ether, the functional group is alkoxy. Okay, alkoxy. Okay, so this is an example of the ether. We call it dimethyl ether. So I can draw the expanded structure for you here. Okay, okay, so again you should be able to circle, okay, to circle the correct region which shows the functional group. So for example, for dimethyl ether, it's this carbon, oxygen and carbon, COC. Okay, so ether, their names will end with ether. Okay, for example, this example is dimethyl ether, so you have two methyl groups attached singly to oxygen. Okay, dimethyl ether. Okay, so next we look at amine. Okay, amine. Okay, so how to identify amine? The carbon will be singly bonded to a nitrogen. Okay, the carbon will be singly bonded to a nitrogen. Okay, so the name of the functional group is amino. Okay, so class of compound amine, the functional group is known as amino. Okay, alright, so for naming wise, it will end with amine. Okay, so this is the simplest example of an amine, so I'll just draw it in expanded form for you. Okay, so methylamine basically CH3. Okay, and H2. Okay, so again you should be able to determine the correct region which represents amine functional group. So carbon bonded to nitrogen. Okay, alright. Okay, next is aldehyde. Okay, so aldehyde, it has C double bond O group at the end. Okay, it has C double bond O group at the end. Okay, so it ends with C double bond OH. Okay, that's how you identify aldehyde. It ends with C double bond OH. Okay, the name of the functional group, we call it carbonyl. Okay, carbonyl is the C double bond O here. Carbonyl, C double bond O, that's the carbonyl. Okay, so this is the simplest example for aldehyde, which is ethanol, or the common name is acetaldehyde. Okay, so for aldehyde, the names will all end with AL. Okay, alright, next we look at ketone. Okay, so if you notice, ketone, they have the same functional group, which is carbonyl. Okay, carbonyl, C double bond O. Okay, but what is the difference between aldehyde and ketone? So if you see here, aldehyde, the C double bond O will be at the terminal, at the end, with a hydrogen, C double bond OH lah. Whereas for ketone, okay, the C double bond O will be between two carbons. Okay, but again the functional group is the same, which is carbonyl C double bond O. Okay, alright. As for naming wise, ketone, they will end with O and E lah. Okay, so for example, this is a ketone with 3 carbons. Okay, so we call it propanone, or the common name acetone. Okay, so we will continue with carboxylic acid. Okay, so carboxylic acid, I think most of you must have heard about it during your SPM chemistry, carboxylic acid. Okay, so it ends with C double bond O OH. Okay, C double bond O OH. Okay, alright. So the name of the functional group is carboxyl. Okay, so kena ingat, carboxylic is class of compound. The name of the functional group is carboxyl. Okay, so as for carboxylic acid, the name ends with oic acid. Okay, for example, you have 2 carbons here, so ethanoic acid, or the common name acetic acid. Okay, next is ester. Okay, so how do we identify an ester? Okay, so ester, it has C double bond O. Okay, and then it forms a single bond with oxygen and another neighboring carbon. Okay, so this is how we identify if there is an ester present in the molecule. Okay, so as for the name of the functional group, we call it carboalkoxy. Okay, for ester we call it carboalkoxy. Okay, alright. So as for the naming, okay, ester, they will end with OATE, OATE. Okay, for example, this ester, okay, it has a methyl group here, and then it has an ethyl group, so the name is methyl ethanoate. Okay, so but don't worry about the naming, you will learn about the naming later on. Just for now, you should be able to identify the region, the correct region, which represents that particular functional group or class of compound. Okay, alright. Okay, next is amide. Okay, so how do we identify an amide? So you have a carbon double bond O and bonded to a nitrogen. Okay, alright. This is how you identify if there is an amide present in the molecular compound. Okay, so the name of the functional group, carboxamide. Okay, so again, when you are answering, it depends on the question whether they are asking for class of compound or functional group. Okay, so as for amide, it will end with amide for their naming. For example, this is an amide with 2 carbons, so the name is ethanamide. Okay, okay, next is acid chloride, or we call it acyl chloride. Okay, so how do we identify that? Okay, so acid chloride ni, it's the same as acid. So acid, just to recall, it ends with C double bond O OH. Okay, alright, for acid chloride, the OH2 is replaced by Cl lah. Okay, halogen, acid chloride. Okay, so as for the naming pula, it will ends with oil chloride. For example, this is an acid chloride with 2 carbons, so the name is ethanoyl chloride. Okay, okay, so we also have acid anhydride. Okay, so how do we identify acid anhydride? Okay, so acid anhydride ni, dia ada C double bond O. Okay, and then singly bonded to an oxygen, and then they have another C double bond O lah. Okay, basically they have 2 C double bond O and oxygen single bond connecting the 2 carbon atoms. Okay, so this is how we identify. Okay, acid anhydride. So the name of the functional group is anhydride. This is the region that you should be able to circle lah. Kalau you, let's say, if you see any anhydride functional group present. Okay, alright. As for anhydride, the name ends with oic anhydride. For example, this one is 2 carbon, 2 carbon, so ethanoic anhydride. Okay, next we look at nitrile. Okay, so nitrile ni is formed between carbon triply bonded to a nitrogen. Okay, C triple bond N. Okay, nitrile, the class of compound. The name of the functional group is cyano, CYANO. Okay, so as for nitrile compounds, the name will end with nitrile. Okay, so for example, this is the simplest compound of a nitrile. So it has two carbons, so ethane nitrile. Okay, that's the name. Alright. So again, to identify nitrile, it must be carbon triply bonded to a nitrogen. Okay, so the name of the functional group is cyano.